Imagine embarking on a journey through the cosmos, where every step reveals a new layer of complexity and wonder. In the field of Vedic cosmology, the line between science and spirituality get blurred. We begin with a familiar concept: space-time. Vedic philosophers picture it not as a static backdrop, but as a dynamic, ever-changing ocean. Within this cosmic sea, chronowaves ebb and flow, intertwining the fabric of time and space. Now envision consciousness as a vessel on this ocean. Typically, we glide across its surface, unaware of the depths below. Yet, as we explore quantum psychomechanics, our vessel plunges into uncharted waters, uncovering layers of reality that elude our everyday perception. It's akin to diving into an ocean where each descent reveals a hidden world teeming with complexity. At this point, you might wonder how these concepts interplay. Here, the Fibonacci sequence comes into the picture, a simple yet profound pattern that echoes through the cosmos, from the spirals of galaxies to the very structure of subatomic particles. This sequence hints at a universal mathematical harmony, a subtle yet powerful force shaping the universe. Delving further, we find the fractal nature of space-time. Like the intricate patterns of a Mandelbrot set, each level of magnification in the universe reveals more complexity. This fractal perspective suggests a symmetry between the vast cosmos and the minuscule quantum realm, a testament to the universe's elegant design. Euler's identity, often celebrated for its beauty, becomes more than just a mathematical gem in our context. It represents a fundamental connection between the universe's forces, a bridge linking the cosmic scale with the quantum. This equation isn't just numbers on paper, it's a poetic expression of the universe's underlying principles. As we venture into the realms of non-Euclidean geometry and complex numbers, we're not just exploring mathematical theories, we're unraveling the fabric of reality itself. Non-Euclidean geometry challenges our perceptions of space, revealing a universe where straight lines and flat planes give way to curves and dimensions beyond our immediate grasp. In this narrative, complex numbers emerge not merely as abstract entities, but as symbols of the universe's dual nature. They embody the tangible and the intangible, the visible and the invisible aspects of reality. It's here, in this intricate dance of numbers and equations, that our theory finds its true expression. Throughout this exploration, mathematics ceases to be just a language. It transforms into a key, unlocking the mysteries of space, time, and consciousness. It's a journey that transcends the bounds of the known, venturing into a realm where every equation, every number, weaves a part of the grand cosmic tapestry. In this ever-expanding quest, our understanding of the universe evolves with each step. We now encounter the concept of quantum entanglement, a phenomenon where particles, regardless of the distance separating them, remain interconnected. It's as if the universe weaves a tapestry where each thread, however distant, is linked in an intricate dance of cosmic harmony. This leads us to ponder the nature of black holes, not just as cosmic vacuum cleaners, but as portals to understanding the fabric of space-time. Picture a black hole as a grand library of information, holding secrets that could unravel some of the deepest mysteries of the universe. The event horizon, the point of no return, becomes not a boundary, but a gateway to new realms of understanding. In the symphony of the cosmos, every celestial body, from the tiniest asteroid to the largest star, plays its part. The music they create isn't just audible to our ears, but resonates through the very essence of space-time. It's in this cosmic melody that we find clues to the nature of dark matter and dark energy, those elusive entities that make up the majority of the universe, yet remain shrouded in mystery. And what of the multiverse, a concept once relegated to the realms of science fiction, now stands at the forefront of theoretical physics? Imagine an infinite array of universes, each with its own laws of physics, its own history, and its own destiny. Our universe, as vast and complex as it is, may just be one note in an endless symphony of realities. As we weave through these concepts, we find that mathematics and physics are not merely tools for understanding, but are the very language through which the universe expresses itself. The equations we write, the theories we construct, are more than scientific pursuits. They are the keys to unlocking the secrets of existence itself. But this journey is not solely about the grand scale of galaxies and universes. It's also about the inner universe, the realm of human consciousness. How does our perception of reality interface with these cosmic truths? Here, neuroscience and quantum physics intersect, suggesting that our minds might be more deeply connected to the fabric of the universe than we ever imagined. In this grand narrative, every discovery, every theory is a piece of a larger puzzle. We're not just uncovering the workings of the cosmos, we're piecing together a story that spans billions of years, from the fiery birth of stars to the quiet glow of distant galaxies. It's a story that's still being written, with each scientific breakthrough adding a new chapter to this epic tale. So, as we stand at the edge of this vast ocean of knowledge, gazing into the depths of the unknown, we realize that the journey is far from over. The universe, with all its mysteries and wonders, continues to invite us to explore, to question, and to marvel. For in this exploration, we're not just discovering the secrets of the cosmos, we're uncovering the story of ourselves, a story that's woven into the very fabric of space and time. As we venture further into the cosmic narrative, we encounter the principle of cosmic inflation, a rapid expansion of space-time that occurred just after the Big Bang. Imagine a balloon inflating in an instant, stretching the fabric of the universe at speeds faster than light. This concept not only reshapes our understanding of the early universe, but also opens doors to profound questions about the nature of space and time itself. In this context, the very concept of time becomes a subject of fascination. Time, often perceived as a linear, unidirectional flow, might in fact be more fluid and malleable than we ever imagined. Picture a river that flows not just in one direction, but meanders through various dimensions, sometimes looping back on itself. This idea of nonlinear time challenges our most fundamental perceptions and suggests that past, present, and future might be more intertwined than we ever considered. As we delve into the depths of quantum mechanics, we encounter the Heisenberg uncertainty principle, a cornerstone of quantum theory that states we cannot simultaneously know both the position and velocity of a particle with absolute precision. This principle isn't just a limitation of measurement. It's a profound statement about the inherent unpredictability of the quantum world. It suggests that at the most fundamental level, the universe dances to a rhythm of probabilities and possibilities rather than certainties. From here, our journey takes us to the edges of human knowledge, to a concept known as the holographic principle. This radical idea posits that the entire universe, with all its three-dimensional glory, might be a projection of information encoded on a two-dimensional surface. Imagine our universe as a hologram, where every part contains the whole and the very notions of space and depth are redefined. And yet, amidst these vast cosmic concepts, we find the role of human consciousness increasingly central. The theory of quantum consciousness proposes that our minds are not mere observers of reality, but active participants. Our thoughts, perceptions, and awareness might be intricately linked to the fabric of the universe, blurring the lines between the observer and the observed, the creator and the creation. In this grand cosmic journey, we also encounter the enigma of dark biology, a hypothetical field that explores the intersection of dark matter and biology. Could there be forms of life, entire ecosystems, operating on principles beyond our current understanding? This idea stretches the limits of our imagination, suggesting that life, as we know it, might be just one expression of a vast, unexplored biological diversity in the universe. As we continue this exploration, we realize that the story of the universe is not static, but dynamic and ever-evolving. With each new theory, each groundbreaking discovery, we peel back another layer of the cosmic mystery. The universe, in all its wonder and complexity, is not just a collection of stars and galaxies. It's a living, breathing entity, constantly unfolding and revealing new aspects of itself. Thus, our journey through the cosmos is an endless quest for understanding, a voyage that takes us beyond the boundaries of the known into the realm of the infinite and the sublime. In this quest, we are not just passive observers, but active participants in the great cosmic dance, a dance that spans the breadth of space and time, connecting us to the very heart of existence. In Caltech Experimental Physics Lab's latest foray into quantum chronodynamics, they conducted an experiment reminiscent of the famed double-slit experiment, but with an unexpected twist. What they observed was nothing short of astonishing. They found that two photons, the basic units of light, could cause interference patterns, a phenomenon one would expect when they travel together. However, these photons were separated not by space but by time, several seconds apart. To grasp the enormity of this discovery, let's paint a clear picture. In a typical double-slit experiment, light behaves both as a particle and a wave, creating an interference pattern when it passes through two slits. Now imagine conducting this experiment, but introducing a time gap between the emission of two photons. Common sense would suggest that no interference should occur, as the photons don't coexist in the same time frame. But here's the bizarre twist. When we cool the system down to near 0 Kelvin, a temperature so cold that almost all molecular motion ceases, we sustain this interference pattern even with a 10-second gap between the photons. In layman's terms, it's as if the photon of light traveled through time itself. The interference pattern, a dance of light and shadow, was only possible if the photons, in some sense, transcended the usual boundaries of time. This groundbreaking discovery opens a Pandora's box of questions and possibilities. If a photon can indeed interact with its past or future self, what does this say about the nature of time? Does it flow unidirectionally as we've always believed, or is it more fluid, more malleable than our current understanding? These findings are not just a footnote in the annals of physics. They represent a paradigm shift in our understanding of the fundamental nature of reality. It suggests that the concept of time, as we perceive it, might be an incomplete understanding of a much more complex, multidimensional phenomenon. This revelation in quantum chronodynamics brings us closer to a theory of quantum temporality, a framework where time itself becomes a variable in the quantum equation. It hints at a universe where past, present, and future might be entangled in a quantum web, much like particles are entangled in space. So, as we delve deeper into this enigmatic world of time-traveling photons and quantum temporal interference, we stand at the brink of a new understanding. It's a realm where the boundaries between science fiction and science fact blur, where each discovery propels us further into the unknown. In this journey, we're not just uncovering the secrets of light and time, we're redefining the very fabric of the universe. It's an exploration that challenges our preconceived notions, inviting us to look at the cosmos not as a static entity, but as a dynamic, ever-evolving tapestry of possibilities. And in this tapestry, time, space, and consciousness weave together to create a story far grander and more mysterious than we ever imagined.